Hello, I'm Do-hyun Lee from Data Intelligence Lab. Today, I will explain our study. Our study is to build an explainable information retrieval model. What is information retrieval? In academic meaning, we have a query and lots of documents called corpus, and our task is to find one or more documents which contain the answer of this given query. Like this document has an answer and others not. And to solve this task, we can consider two kinds of models. Left one is a well-known BERT model, which use the merged input query and document as one input to produce a BERT score of these two documents and queries relation. And the right one shows the two-tower model. RepBERT is the well-known model of this kind. This kind of model use only one type of input. For example, query becomes on query embedding and document becomes an document embedding respectively. And to make a score, we use dot product of both embedding. Then we have a scalar value, so we can use it as a score like BERT score. This is also called dual encoder. In our study, we use two-tower model instead of left one because in BERT model we cannot pre-compute anything of query or documents, but in two-tower model we can pre-compute document embedding before any query is given. So in real inference time, we only need to make an embedding of query. And query is in most of time much shorter than document. So in two-tower model are much faster than normal BERT like transformer or something models. So, and in IR task we have very lots of documents, so in many time algorithm or system requires only linear time or sublinear time to search. Therefore, we will use two-tower model. And one more important thing is topic embedding. Let's give an example. We have one query and two documents. The query is who is the CEO of Google, and document 1 says Sundar Pichai is the chief executive officer of Google, and document 2 says Mark Elliott Zuckerberg is the CEO of Facebook. As you know, document 1 has answer and document 2 has not, but in the word level matching score, document 1 doesn't have CEO exact match word, it just said chief executive officer instead. However, document 2 has CEO, so in BM25 or BERT, it can be give a high score to document 2 even though it doesn't have answer. However, we can consider the topic of this given text. For example, the query's topic is CEO and Google, and document 1 topic is CEO and Google also, and document 2's topic is CEO and Facebook. As you can see, document 1 has same topics as document query, however document 2 is not, and the chief executive officer is become to CEO topic. Therefore, in topic space, we can correctly select document 1 as answer. As topic as embedding, we can say first digit means CEO, and second digit means Google, and third digit means Facebook. Then it looks like this. And Korean document has 2 matching, and Korean document 2 has only 1 matching. So the matching score in topic space, document 1 has much higher score. So the overall method looks like this. The left one is query, how to get query embedding, and right one how to get document embedding. It's also same. In query, we can make on BERT embedding through RepBERT, and topic embedding through topic model, and also for documents, and then we can dot product to get a score. And one more, we need to visualize this result, so we also use attention layer in here instead of just dot product. Therefore, we can get a word level relevance score. How it looks like and how it works I will explain it later. Hello, I am Do-hyun Lee from Data Intelligence Lab. I will show how to visualize the retrieval result first, and then explain the overall process. To visualize our result, run visual.py file with 2 arguments, query and doc. Let's see, Python visual and query blah blah, and then doc. For example, if the query is where is the capital of Korea, and the candidate document is Seoul is the capital of Korea. Then you can write like this. One important thing is you should use underbar instead of space. Then just wait. This is the visualization result. The words in red cell means it has high attention score. In other words, how important the word is when the model rank the given document. And this is another example. I prepared it. The question is about the knee and joint. As you can see, those keyword knee and joint has high attention scores in this visualization results, like here and here or here. Let's see how our data looks like. The main data is collection.tsv and queries.dev and train.tsv and the topic files. Let's see collection files, how it looks like it. It is a TSV file, so we use tab as an indicator to separate the values. In collection.tsv, we first has the ID of each passage, and the passage text is following, and each line has one passage and passage ID. And in query files, it has same form, the query ID first and tab, and then query text is following. And how topic looks like, it is a JSON-L file, which means each line is a JSON file, and each line has a PID of that corresponding passage and which topic it includes. For example, in first passage has an ID 0, and it has 8 topics, 21 topic ID 21 and 30 and etc.